Hello everybody, this is video 4 of week 2, and in this video I'm going to sit and work some examples about how you can expect to work with the metric system in this class. So the examples I'm going to do are representative of examples that you'll have on the homework and things that you might encounter on quiz 1 and exam 1. I'm going to be working on my tablet again, and I think I've got the sharing process pretty much mastered now. You can all laugh a little bit whenever I don't do this very smoothly. All right, that was pretty simple. So I have 4 examples here, and I'm just going to work through the solutions. I'm going to write the solutions in red. Feel free to work through these as many times as you would like to rewatch the video. Make sure that you get this process and you can answer these 4 questions. And at the end of this, I'll point you towards where I have some practice problems with an answer key so you can actually practice on your own. Okay, so our first example, question number 1. 12,000 meters is how many kilometers? So the first thing that I want to do is I want to note that I'm going to be going from meters to kilometers. And I have 12,000 of these meters. This is what I'd rate as a pretty easy question because you could probably already start guessing what the answer is. 12,000 meters should be 12 kilometers because kilo means 1,000. But I'm going to go ahead and show you a couple of ways that you might want to approach this. Since it's a simple example, it'll help us scale to more complicated questions. So I'm going to rewrite the 12,000 meters as 12, but instead of the 1,000, I'm going to write it in scientific notation. So I have 10 to the third meters. Remember that kilometers, that's 10 to the third meters, so this really is saying 12 kilometers. So this was a pretty easy example. Let's go through the formal way to do this. You might have some flashbacks to the train tracks method of unit conversion. We're not going to be doing any complicated ones, but I want to show you the process, the formal process you would run through. So what you could do just come down here and write out what you were given, 12,000 meters. And then what I want to multiply by is a fraction that is unity, just 1. And I want to go from meters, and I want to convert to kilometers, kilometers. So I want this to be 1. So I would say, oh, well, 1 kilometer is the same as 1,000 meters. So 1 kilometer divided by 1 kilometer, or 1,000 meters divided by 1,000 meters is just 1. And now you can go ahead and cancel out your meters, have these 3 zeros here, so cancel out those 3 zeros, and you're left with 12 kilometers. So this process right here is going to be a staple that is guaranteed to work no matter how complicated the situation gets. You just have to keep track of things as you move along. All right, let's move to the second example. Getting a little bit more difficult here. So we have 0.8 millikelvin is how many microkelvin? So this one is slightly more complicated. So let's go ahead and hit it with the guaranteed method where I'm going to write down what I know. I was given 0.08 millikelvin, and I'm going to want to convert that to microkelvin. Okay, so now we have to ask ourselves some questions. I want to put millikelvin down here. Milli, so milli is 10 to the minus 3. Micro is 10 to the minus 6. So notice there's a difference of 1,000 there. There are 1,000 micrometers and 1 millimeter. So I would have, there are 1,000 micrometers and 1 microkelvin and 1 millikelvin. So now I can cancel out, and I have 0.08 times 1,000, which equals 80 microkelvin. All right, a little bit more difficult, but still nothing that's too hard to handle. You could also go ahead and logic this one out and write it out in words. So there are 1,000 microkelvin and 1 millikelvin. So if I have 0.08 millikelvin, and I know there's 1,000 of those, to go to microkelvin, 0.08 times 1,000 equals 80 microkelvin. Not too bad, or at least I hope it's not too bad. And if you had trouble following this one along, just stick with us for the next example. Post something in one of the Canvas discussions about the week 2 material. But let's move on to example number 3. Here, I'm trying to step up the difficulty just a little bit with each example. Now we're going to take 74,000 kilohertz, and I want to know how many gigahertz this is. In this one, I'm going to go through a complete process because you're jumping a couple of scales here. Because kilo, and I'll go ahead and write that down because it always helps. Kilo is 10 to the third, 1,000 of something. Giga is 10 to the 9th. So it's a difference of 10 to the 6th. It's 1,000,000 times bigger. All right, so let's do the formal way first. Start with what I know. 74,000 kilohertz. And let's go ahead and just put this in hertz and then take the problem from there. All right, so if I want to go to hertz first, here I have kilohertz. I want to go to hertz. So I know that there are 1,000 hertz and 1 kilohertz. So I have 74,000 times 1,000. Hertz. And you can go ahead and crunch that out to be 74000, and then 3 more zeros equals 7.4 times 10 to the 1, 2, 3, 4, 5, 6, 7. Okay, so now I have the number of hertz. 7.4 times 10 to the 7th hertz. All right, now let's work with that. 7.4 times 10 to the 7 hertz. And remember, I'm going for gigahertz. So I want to go from hertz. So these two will cancel to gigahertz. Well, how many hertz are in a gigahertz? Giga is 10 to the 9th, a billion. So there'd be 10 to the 9th, 1 billion hertz and 1 gigahertz. And now if you can remember how to work with exponentials, this is pretty easy because you have 10 to the 7th divided by 10 to the 9th. We can cancel all of that out. 9 minus 7 is 2. So we have 7.4 divided by 10 to the 2 equals 7.4 times 10 to the minus 2. And now we could go ahead and move our decimal place over 2 hops and get 0.006 0.074 gigahertz. Not that bad so far. A little bit more complicated, right? But I think you can handle it. All right, and I want to show you, since this one is a little bit perhaps more difficult, maybe we should consider it in some other way. And now I want to just use the fact that kilo to giga is a factor of 10 to the 6th. So let's go ahead and erase a little bit. It'd be nicer if these things are bigger. Sorry for erasing something that was already there, but I know that the difference between these here is a factor of 10 to the 6th, a million times different. And now I can use that and go 74,000 kilohertz to go directly, because I know that there would need to be 10 to the 6th kilohertz and 1 gigahertz. And now I can go directly, cancel, cancel, and I get 7.4 times 10 to the 1, 2, 3, 4 divided by 10 to the 6th. Equals 7.4 times 10 to the minus 2 equals 0.074 gigahertz. Just always good to double check. 1, 2, yep, that would get me back. All right, so that one was, I think we can all agree, a little bit more difficult. Rewatch this part, work through the practice examples. Now I want to ask you a different style of questions. Question. So which of these 4 distances is the longest? And perhaps this part, I'm going to show you a slightly another method that might help you with all the previous questions. So which of these distances is the longest? Is it A, 0.0003 gigameters? B, 2 times 10 to the 5th millimeters? C, 40 kilometers? Or D, 9 times 10 to the 8th micrometers, 9 times 10 to the 8th microns? Seems like a very, very complicated question. But what I want to do is I want to exploit my knowledge of what these prefixes are. So the first thing that I'm going to do is I want to compare all of these in a common unit. Let's just go to the base unit, the meter. And what I'm going to do is I'm going to get rid of the letters. So here we have gigahertz, but I know that's a 10 to the 9th meters. Here we have millimeters. I know the milli is 10 to the minus 3 meters. Kilometers, that's 10 to the 3 meters, 1,000 meters. Micro, that's a millionth of something, so that'd be 10 to the minus 6, 1 divided by a million. And now I can just easily convert these all to a common unit, our base unit, the meter. So let's go ahead and put this in scientific notation. We have 1, 2, 3, 4, 5. 3.0 times 10 times 10 to the 5th. I still have the 10 to the 9th. Sorry, 10 to the minus 5th times 10 to the 9th. So 10 to the minus 5 times 10 to the 9. This would equal 3.0 times 10 to the 9 minus 5 is 4. So that equals 30,000, 3 times 10 to the 4th meters. Okay, one of them is converted to meters. This one will be a little bit faster and easier since it's already in scientific notation right here. And we would have 2 times 10 to the 5th And I knew that milli was times 10 to the minus 3. So times 10 to the minus 3 meters. 10 to the 5th times 10 to the minus 3. 5 minus 3 is 2. That gives me 2 times 10 squared equals 200 meters. All right, now down to our 40 kilometers. So we have 40. The kilo means times 10 to the 3rd, so times 10 to the 3 meters. 40 times 10 to the 3 would be 4 times 10 to the 4th, which equals 40,000, 1, 2, 3, 4 zeros, meters. And now our last one. Let's move these micrometers to meters. Here we have 9 times, write that a little more clearly, 9 times 10 to the 8th. The micro means times 10 to the minus 6, so times 10 to the minus 6 meters. 8, 10 to the 8th times 10 to the minus 6. 8 minus 6 is 2, would be 9 times 10 squared meters equals 900 meters. So now I have all of these numbers in meters. And I just have to answer which of them is the longest. 30,000, 200, 40,000, or 900. And that gives me C. The 40 kilometers was the longest distance. So those are the 4 examples that I have for you. I do want to end this video with one last thing. I want to point you to the resources that you can find on Canvas so you can continue practicing past just the examples. I could sit here and work examples over and over and over, but I want a video that's not going to be hours long. So what you should do is go ahead and go to Canvas. So you should be able to see the Canvas page here. It's pretty much the same right now for 151 and 152. So the layout's the same, and you want to go all the way to the bottom of our home page, and here you can see practice problem sets. These are all optional. They're just PDFs, and I provide a PDF that just has the questions, and then I have the answer key. Work through the PDF that just has the questions, come up with your answers, and then check them versus the answer key. Don't go directly to the answer key. Then you're just memorizing what the answers are should be instead of going through the process of learning. And it's through that process that's whenever you're actually learning the methods and how to solve these questions, so you're not blindsided on a quiz or an exam. So if I click on the PDF, you can actually see what the PDF looks like. I recommend downloading it so you can work on it offline. So I walked through what scientific notation is in the metric system. I give you some practice of writing numbers in scientific notation. I didn't make a video on that. And then you have metric system and the prefixes. I give you a little primer and reminder of how to work with that. And I even ask you to complete this table to help hammer in what the prefix is and what number it associates to, and what the prefix actually is, what the symbol is. And then I have a series of questions that you can work through, and then you can go check your answers on the answer key. All right, so I've never done a video like this where I'm working examples with a tablet. Hopefully that was helpful. If you have any questions, please let me know, post them on Canvas, and thank you for tuning in.